Sometimes in a computer program, we have more than one thing that's going on at the same time. There's many, many reasons why this could be done. It's not always done, but it's often done. And actually, the GUI programs that we've been building to this time are do this automatically, whether you realize it or not. It's automatically happens here. But the strategy behind this is around the idea that some jobs are just easier or more quickly done when there's multiple people contributing. So if you're going to make a big fancy dinner, you can have one person do all the work. This is the way I've always kind of been as a cook. I'm not great at splitting tasks with others. I mean, I can. People have to know pretty well, but I don't. Anyway, I can put together the ingredients. I can go shopping. I can, cook them. I can put them together. I can put them on a plate. I can serve them. All that stuff together. But in reality, that's not the most efficient way to get things done. Have one person do it. So if I break up the work, I can get stuff done quicker. I can get stuff done more efficiently. So in a restaurant, I normally have some people up front that are taking orders and corresponding with the customer, and then have people in the back end who's actually doing the cooking and everything else like that. And so they trade off part of the responsibility. There's some people that are doing work at the same time, because they can be cooking while they're talking to the customers at that point, but then also that they can have to have communication going back and forth. And that's what we're going to get into here when we're talking about concurrent programming. So the idea behind this is sometimes referred to as parallel processing. A computer essentially started off to do one thing at a time. Think of it this way. If a computer's a car has one destination it's going at a particular time. There might be stops along the way, but you can't drive to the airport and drive to the movie theater at the same time. I can go to one, then go to the other. And that's fine. You can do that. But sometimes you need to go both places at the same time. And so as we expand in computers, as we go further, we find different strategies for solving this problem. We can use multiple processors, multiple processes, or multiple threads to solve these different types of problems. And we can do any of these within Java or many other languages that's going on out there. Let's dive into them a little bit more detail here. So we say multiprocessors. Generally what this speaking is having multiple computers. So that would be like, right now I'm recording this on one computer, and you will watch this later on a different computer. And it's not exactly the best analogy there because they're doing it at different times, but the point being is we have multiple computers and they're sharing information across those multiple computers. I've uploaded to the server, you've downloaded the server. The fact that we talk is more about distributed computing. It's about networking. It's about things like that. This is the way the internet works. This is the way you'll learn in future classes. You'll learn about sockets and the way we can talk about multiple computers like that. Now, multiple processors does start to come into a single computer to some degree because now we have multi-core processors. You have a quad core or an 8-core or whatever, dual core or whatever there's going to be, where you can actually have more than one thing happening at the same time on an individual computer. And this still sort of kind of fits into it because there's multiple hardware pieces that can run instructions at the same time. It doesn't fit into what we're trying to do. I just want you to be aware that that's one strategy, is just have two physical pieces of hardware to run two programs at the same time. Now, the other alternative, and this is more likely what's happening in your multi-core PC, is you have multiple processes on the same computer. So this is like you're watching this video in whatever your playback tool is, but you also have a web browser in the background, and perhaps you have your email backup in the background, and you could have a video game off to the side you're not playing right now, and so on and so forth. Every time you hit Alt-Tab on a Windows machine or whatever the equivalent is on the Mac, I'm not a Mac user, that's multiple processes, and you jump between them. And so the responsibility of that is the operating system. It's your Windows, it's Mac, it's Unix that's telling you which process gets to run at a given time. And you're writing multiple Java applications to make this happen. So in the multiple Java applications, we have to have a Java virtual machine to run on each one of them. And then we can go through each one of them and be able to isolate them and run them. So what we're talking about here is where we have one Java virtual machine and we have multiple threads, it's an important term to put out there, that are running within that Java virtual machine. There's one Java application that's running. So we're going to have a single program, and that single program goes back and forth in between different things that are happening at the same time. The biggest advantage here is I don't need to share data across a whole different socket or file or however I'm going to be sharing data that way. I can share it within my application. We're in the same Java application. I can just immediately go and access information. I can access whatever's going on in that Java program for me already. So that's what we want to talk about here. So the question comes up is, what is a thread? So a thread essentially is kind of like a speech. It's a set of instructions. So when you get a speech, you have a teleprompter, you start at the beginning, you read it down to the end. That's the exact same thing that threads do. It's a script of essentially a method. Now, that method is not limited to one. So like if you're reading a speech, you can have a speech that refers to another book. You can read a quote from another book. I mean, this is the way most sermons happen in church. The pastor's going along and they have their own speech, but then they stop and they open up the Bible and you read from the Bible a little bit and you go back to their speech, and that's exactly what a thread is. It's basically a method where I jump around and call whatever other methods I want to have happening. But there's a specific method that gives me the instructions that are happening as part of that thread. Now, like a speech, when it's over with, it's done. A thread is not a method that gets reused and recalled as much as it wants to. It's not like every other method. A thread is a very special type of method that runs one time, and then the results of that is finished. We'll see how that gets put into the language here in a little bit. So since Java is an object-oriented language, all work inside of Java happens inside of objects. So a thread is another special type of object. As we were just saying, the thread's instruction sets can come from any other thread. I can call methods on any other thread. I can access data from any other thread. I can have many of these threads out running and sharing objects. They can go and use the same sort of data that's happening inside of there. And so you have to differentiate the object from the thread of execution that's going about that object. So now one thread can go through multiple objects in the same objects, and two threads can be potentially using the same objects at the same time. So this is a lot of power, but it's not without a certain amount of risk. When I have two threads potentially using the same resource at the same time, it's like the real world where I have to have communication. I have to have some way of answering emails, picking up the phone, sending emails, whatever I have going on inside of there. I have conference rooms or projectors or whiteboards or whatever I need to share, and sometimes I have to wait for certain things to happen. I have to wait for the beginning of the trading day to start doing trades and things like that. So all these things have to be coordinated. I can't just have threads out doing whatever they want to anytime and stepping on each other and the work that they're trying to get done. And you have to remember that single processor is always a shared resource. Even if you have multiple cores inside of there, I don't control that. That's controlled outside of my function of writing Java code. And so I have to take it into account that that thread may or may not be running at any given time, because that processor, just like a bike or a chair or a phone or a pen, can only have one set of instructions happening at a time within that. And so we have to be aware that processor is something out of our control when we're designing this. It's something that's controlled by the Java virtual machine, and more importantly by the operating system that underlies the Java virtual machine. We can only control up to a certain amount of what's happening inside of our application. We plan for it, we accommodate for it, but then we give up the control to our runtime environment. And that JRE, the Java Runtime Environment, that's doing a lot of that work for us. So when we go through and we want to accommodate for our system, we basically just code around it. We just code to plan for it. The Java Runtime Environment becomes our adjudicator of which thread gets to run at one different time. And that judge that's out there is smarter than we are. The reality is, if we controlled everything, we set priorities, we said this thread runs now and that thread can't run, we'd probably screw it up. I've done real-time systems, and it's actually counterintuitive. Some of the things is like, well, this is the most important thing, make it the top priority. That sometimes can screw up the whole system where nothing works properly. And so we let the Java runtime environment use its round-robin scheduling, and we tweak the hierarchy, we tweak the importance, but unless something's absolutely critical, which we have ways of coding that, which we'll see later on in some of these videos, we kind of just let the scheduler do its thing. For the most part, everything gets done. It's pretty happy. If you want to see good examples, look at Windows when you hit Alt-Control-Delete as a user and nothing happens. It's because their threading hierarchy is a little bit, their processing hierarchy is really a little bit screwed up. In my opinion, if I'm a user, I hit Alt Control Delete, everything should stop because I'm the most important person. But at the same time, if I'm a stupid user, I could screw up the computer in many bad ways within that. So they've got some sort of balance inside of there of which threads get which priority, and it's smarter than what us as an average developer is going to be. So just know that we're only going to have a limited amount of control. We're going to see what control we have, but it's not going to be complete. All right, so that's the idea of a thread. Now the next step we're going to look at is how do we control a thread, how do we build a thread, how do we create it in Java. But for now, just take this knowledge of what a thread does and what our purpose is. Threads aren't super common, but when you need them, they're an invaluable tool.